Hello, very warm welcome. Today we are looking at another LeetCode question, which is graph bipartite, and we need to kind of return true or false if that stands out to be true. Right? What we are given is an undirected graph which contains n nodes, and each nodes are numbered between 0 to n minus 1. And we are given a 2D array which says that okay, where the graph u is an array and the number of u it is adjacent to. What I mean by that is, if I am given a 2D array which says, so if I've given a 2D array which says 1, 2, 3. So if this is at index 0, then it says my 0 node is connected to 1, 2, 3. That means it's connected to 1, it's connected to 2, it's connected to 3. Right? Similarly, if I look at 1 index, my node 1 is connected to 0 and 2. So in a way, if you see, right, it's a unidirectional graph. So if this is true, then this is true. What it's saying is, if 1 is connected to 0, that stands true, and 1 is also connected to 2, so that is also connected to 2. Right? Now 2 is connected to 0, 1, 3. Now 2 is connected to 0 and 1, that stands true because we already kind of established that with the first two indexes. 2 is also connected to 3. As well as 3 is connected to 0 comma 2. 3 is already connected to 0 comma 2. Right? So this is how my graph is built up, and sorry, 0 is also connected to 1 to 3 and so on. Okay, so if you see, this is what it turned out to be. So 0 is connected to 1, 2, and 3, right? And 3 is connected to 0, 2, 0 is connected to. So I think you have got the gist of it, that how the nodes are connected to each other. Now we need to see uh, what a bipartite graph is, right? So what a bipart is that if the nodes are partitioned between two independent sets, such that every edge in the graph connects a node in set A and set B, right? What I mean by that is that if I try to bifurcate this in two sets, then all the nodes should be connected to each other, right? Now if I look at this example, right? If I look at this example, say 0, 1, 3, 2, right? Now if I try to so these are connected like this, right? If I move them into two sets, say 0 and 2, 1 and 3, so it's something like this, right? This, right? This is one step, this is one step, this is one step, right? So if that stands out to be true and all the nodes are connected, then we call that a bipartite graph. Bipartite graph. Now, how to approach this problem, right? If you see, again, this is a graph problem, so obviously the things which you will rely back to is a best first search or best first search. But how will I leverage that best first search or best first search? So how will I do that is, so if I have these nodes, right? Say these nodes, and these are connected to each other. What I'm going to say is, I'm going to give them, you can say, a number. So I'll assume all are by default 0. I'll by default give them index 0, and I'll say if I'm accessing a given node and it is not colored, I'll give them as 1. Right? Now I'll look for its adjacent nodes, which are these ones. I'll mark them as say 2. Right? And I'll look for their adjacent node. I'll mark them as 1 back again. Right? In a way, or if you put it in a different manner, that I'm going to say um color them as red and blue. So idea is that if a given node is colored or it's already marked as to a given number, which is say 1 or 2, which I just showed, and if I try to update that back to a number 2, for example, what I'm trying to say is, say I had another road, this one, right? I already updated that to a 2, right? And if I'm working on this index and it says that, okay, no, this has to be a 1, right? Then that means it's no longer a bipartite drive. So if two particular nodes are trying to kind of color or try to update a given node with two different numbers or two different colors, then in that sense I'll say, okay, no, this is not a bipartite drive. If if at the end of the day, when I'm traversed through everything and they are all you having a unique color associated to them, I'll say yes, they are bipartite graph. So with this, let's get going. I'll use BFS approach because I'll just look for adjacent node, work them through, and then go right. So the moment people will talk about you can say a BFS, then the first thing which comes to mind are the queues because you add to the queue, you work on that queue, and you move forward. Right. So this is my queue. Now what I'm going to say is I'm going to color them in, or you can say uh, I'll mark I'll mark them say one or two, right, based on whatever I understand. One or minus one, one or two, whatsoever you want to kind of call it. So let me create a marker which says new int graph dot length. Right now I have this marker created. Now what I'm going to do is I'm going to iterate through each and every index in this given array to me less than graph dot length I plus plus, and as usual I'll add it to my queue. But before doing that, right, because I'm going to see whether a given node which I'm going to work in is already you can say flagged or not, right? What I mean by that is, say I'll assume that the as I said, right, I'll assume all them to be zeros, right? So if they're already if they're all zeros, then only I kind of mark them as visited, right? For that matter, let's make it to visited, right? So if say my color or my visited I is double equal to 0, then only I'll go and do the manipulation, right? Then only I'll work on that particular node, right? So what I'll do is first I'll add that to my queue. Now I added my that particular index to the queue, and I'll say okay, my visited I is now updated to 1, right? Now with this, what I said, okay, I started with say 0, I updated to 1. Now I need to look for its adjacent nodes, which are these ones. I'll have to mark them something. So I'll say, okay, if this is 1, I'll say this is, for simplicity, this is minus 1. Say, right? Uh, Here, 1 signifies, say, you can say a given color which is blue, and say minus 1 signifies a given color which is red. So if this is blue, this is red, then this will always be red. These two will try to mark this back, this node 2 as blue, right? So this is what the thought process is. So once I am at this node, I'll mark that as 1, which in this case signifies, say, blue color, or you can say index 1, whatsoever you want to kind of under, however you want to process it. Now I'll go through this queue until unless it's not empty. This is what you generally do, which you generally do uh, in the BFS approach. We add it to the queue, we iterate through that queue until unless it's empty. And what I'm going to say is I'm going to get the first node which is being enqueued into it. That will be say my queue dot dq. Right, in this position what I got back is say 0 with the example which I talked about. Right, now I'll say now what I'll do is I will. So what my graph 0 contain? 1, 2, 3, or in this example 1 and 3. Right? Now I need to go through 1 and 3. Right? So I'll say for each where n in graph node. Right? So what this will give me? This will give me graph of 0. Graph of 0 is 1 and 3. What I will check first is if my visited, say my current node value is equal to what my visited my parent node is, which is this one. So what I'm saying is if this was 0, this has to be 1. So I'm saying if this is 0 right now, or I updated this to 1, right? So I updated this to 1. So what I'm trying to say is if this is updated to 1, I'm saying this should not be 1. This should not be 1. This should not be 1, right? If that would have been 1, then I'll say okay, these my two colors are adjacent to each other, or you can say I'm trying to update the same color again with the parent color, then that would be something which is wrong, and that's why I'll return false, right? So I'll just say okay, if my parent and child are, you can say, not having the same color, if that stands out to be true, I'll return false. That means I'm trying to update the same node with two different colors. If otherwise, if they are of different colors, or you can say if they're not the same colors, and my child node is not colored, right? If my child node is not updated to a given number, I'll say visited of n is double equal to 0. I'll enqueue that to the given my queue dot enqueue in this position n, and I'll mark that to be visited to be minus of, we said right, 0 1 minus 1. I'll say visited of n will be equal to minus of visited of node. I hope you understood this. If by chance we end up this loop and everything is done, I'll just return true because my whole set is complete and I didn't encounter a given node which is being tried to update again with another node, right? So just to iterate again, what we did is we took this node, updated to 1. We looked at its neighbors, we updated to -1, and then we looked at their, as say I picked this one, say updated its neighbor 1. If I'm at this one, so if I look at these two, this is -1 -1, this is again 1. So this turned out to be a bipartite graph because I'm not trying to update anything. Now if I look at this one, right, if I update it to 1, I updated these to be -1 -1 -1, right? Now if I'm at this particular node, if I'm one node, right, if I look at it adjacent, this is correct, this is not the same node, but if I go to this one, these two are turning out to be the same indexes or same values associated to them. Then and there I'll say okay, no, my particular parent node and its child node or the adjacent node are of having the same indexes, I'll return false, right? This is what we're trying to do here. We we looked at it, we saw okay, its agencies are like the the values inside the particular nodes are of a different of the same color. Then I assume okay, no, this is not going to be bipartite graph, I'll return false then and there, right? So let's run this through and see what is happening. It got accepted. Let's submit it. Cool. So this is, guys, I hope you understood it. It's about how you're kind of marking the adjacent nodes and trying to see that okay, how those markers are working using the best first search approach. You can do the same using DFS approach as well, and you can take that as, you can say, another tryout mechanism that okay, how to do it in using best first search approach. With this, I'll take your leave. In case you like the explanations, please do hit the like button. In case you're new to the channel, please do subscribe. And in case you still have any questions, any doubts, please reach out to me in the comment section. Thank you, guys. Thanks a lot.